WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Hello learners, you are welcome to Eko Learner Support for WAEC and NECO candidates. My name again is Kamaldeen Abiona. I'll be taking you mathematics, and the topic for today is sets.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So welcome to the world of sets. So in this lesson, we'll be exploring the basics of sets, which are fundamental to building blocks in mathematics. So you think of a set as a basket full of different fruits. We have mangoes, we have pineapple, and lots of fruits like that. So today we'll be learning how to define sets, represent sets, and perform operations like union of sets, intersection of sets, and at the same time complement of sets. All right, so what is set? We can define set as a collection of well-defined objects. Like I've mentioned, it could be orange fruit, for example, orange, pineapple, banana, and so on. So those are the examples of what we mean by sets. Now, each object in this particular set, we call it element. So element of a set. So think of fruit now. Banana is an element of the set fruit. Orange is another example, is another members of that particular set. So I have some sets here. Set of even numbers less than 10. What are the set of even numbers less than 10? Even numbers, can you remember? Numbers that are divisible by 2. So we have 2, 4, 6, 8 as elements in that particular set. So these are key points. Set can contain any type of object, including numbers, letters, words, or even other sets. Then another point there is no repetition. For example, look at this. We have a set of 1, 2, 2, 3. It's actually the same as set of 1, 2, 3, since the number 2 is repeated. Then at the same time, the order does not matter. The set 1, 2, 3 is the same thing as the set 3, 2, 1. They are identical. All right? So there are several ways in which we represent sets. Two common methods are used. And the first one is listing method. And another one is what? Set builder notation. Now the first one, listing method. This method involves listing all the elements of the sets within a curly braces. And an example is what? The set of vowel letters of English alphabet. And we have A, E, I, O, U. The second way in which we can present a set is set builder notation. So this method describes the element of the set using a rule. For example, the set of all even numbers. How do we write it? So x such that x is an even number. So that is enough to what? To represent that particular set. So understanding the concept of set. Yes, there are some terms that we need to understand in set. So one of it is empty set. What do we mean by empty set? So this is a set with no element. It is denoted with that sign. Or we use this empty braces. So that is an example of what? Empty set. That is how we write it. We also have what we call finite set. When do we say a set is finite? A set is finite if it has limited number. An example is set A equals 2, 3, 4. We have just 4 numbers there. So because it has limited number of elements, we call that what? A finite set. And we have another set, a set with unlimited number of elements. That is infinite set. Can you think of anyone? An example is the set of all natural numbers or the set of all integers. How will I write that? Set B, the set of all natural numbers. What are natural numbers? They start from 1, 2, 3, 4, and it does not have an end. So this is how we represent a infinite set. So it has an unlimited number of elements. All right? So another thing that we also need to understand there is what? Universal set. Universal set is another term. So what do we use it for? So universal set is denoted by this U, and it represents the set of all elements under consideration. We say it's a parent set from which all other sets are derived. So universal set, we can write it like this. Another notation is this. So that is how we represent a universal set. We also have what we call subset of a set. So what do we mean by subset of a set? When you say a subset, it means part or the whole of a set. So we say that a set A is considered to be a subset of the set B if every element of A is also in what? In the element of what? Is also an element of what? B. Now, how do we do that? For example, A could be set 2, 4, 6. And set B be set 1, 2, 3, 4, 5, 6, 7. All right. So from here, let's check. All elements in A, are they also in B? Let's see. 2 is in A, 2 is also in B. 4 is in A, 4 is also in B. 6 is in A, 6 is also in B. So hence, we conclude that what? A is a subset of B. So how do we write that? We use this. A is a subset of B. All right. So the next thing that we also need to define there is what? Cardinality of a set. What do we mean by cardinality of a set? This is what? The number of elements in a set. For example, this is set 2, 4, 6. The cardinality of what? Set Y is what? Is 3. Because what? We have 3 elements. That is 2, 4, 6. So that is what we mean by the cardinality of a set. Now, we have been able to define different sets or different terminologies in sets. So how do we combine them together? Like you all know, you can always add 1 and 2 together, 3 and 4 together. So how do we combine elements in sets? So we have the union of two sets, A and B. Union is one of the set operations. Operations, when we say operation in mathematics, we use it to combine two or more elements. All right? So, union of a set. It means what? It contains either A or B, meaning you are merging two or more sets together without repetition. Don't forget, without repetition. All right? So, example, we have set A is 1, 2, 3. Set B is 2, 3, 4. Then what is A union B? So A union B means we are merging the two elements of the set together without repetition. All right? So what do we do? 1, 2, 2 we have double 2, but you write it once. 3 and 4. So that is what we mean by A union B. All right? So another example. Now look at this. I've used the listing method here. This is set builder method of presenting our set, like I've mentioned earlier. So Q, set Q is a set of what? Numbers from 0 to 30. And then S is what? Is what? A perfect square. All right. So can you think of what X means? X is the element of Q. And it is what? Between 0 and 30. And at the same time, X is what? A perfect square. So it means we are thinking of perfect squares between 0 and 30. Between 0 and 30. So let's look at that. Perfect squares. What are perfect squares? So in this, you need to understand, you need to remember all those concepts that you have learned before. So perfect squares, numbers that can be expressed as the square of another number. So e.g., 1 square is what? Is 1. So that's the perfect square. 2 square is what? 4. That's the perfect square. 3 square is what? 9. 4 square. 4 square is what? 16. Yes, 5 square is 25. 6 square is 36. But it is between 0 and 30. So we stop there. So this is set Q. All right. Set P is what? X. Such that X is between 1 and 10. And X is what? An odd number. So it means we are looking for all odd numbers between 1 and 10. All right. So how do we do that? Not odd numbers. Numbers that are what? Not divisible by 2. All right. So let's go. What are the numbers? 1. The next one is 3. The next one is 5. Between 1 and 10. The next one is 7. The next one is 9. Between 1 and 10. 11 is more than 10. So you stop at 9. So we have been able to get set Q and set P. All right. So the next stage is find Q union P. Q union P. Don't forget, union means merging the two sets together without repetition. All right. So let's do that. Q union P. So let's merge 1, 3, 4, 5, 7, 9, 16, and 25. All right. So that is Q union P. I hope you understand that. That's good. All right. So let's move to the next one, which is intersection of what? Two sets. So what do we mean by intersection of two sets? We denote that with N, A intersection B. And it is what? The set of all elements that is common to both A and B. All right. Common to both A and B. So let's take an example. Let A be the set of 1, 2, 3, 2, 3, 4, B. Then A intersection B means you what? You bring them together. What is the common element? All right. 1 is not common. 2 is common. Yeah. 3 is common. So A intersection B is what? 2, 3. So that is A intersection B. We also have the same question we dealt with the other time. That is Q which is perfect square. What are the perfect square? Do you remember again? The perfect squares are 1, 4, 9, 16, and 25. And the odd numbers are 1, 3, 5, 7, and 9. So the question is, find Q intersection P. Find Q intersection P. So how do we do that? From the definition, Q intersection P means element common to both. Common to Q and P. So let's check for that. Yes, 1 is common. 3 is not common. 4 is not common. 5 not common. 7 not common. 9 common. Good. So I think that's all. Yes. So hence we say that Q intersection P is 1, 9. Okay. So that is Q intersection P. So that is what we mean by intersection of two sets. Now, the next one is complement of a set. Complement of a set. So what do we mean by complement of a set? The complement of a set denoted with A prime or A complement is the set of all elements that are what? That are in the universal set but are not in A. Not in A. So another name for that is not A. Not A, but in the universal set. An example, let's consider this. The universal set is 1, 2, 3, 4, 5. And there A is 1, 2. So then we can see that 3, this is 1, 2. 3 is not there. It's not in A. 4 is not in A. 5 is not in A. So A complement is 3, 4, 5. So that is the example for that. All right, let's make a recap of what we have learned today. We have learned about union of sets, intersection of sets, and complement of sets. So let's apply that here. Question 1, find the union of sets A and B. Union of set A and B. Union of set A and B. All right, so we merge the two sets together without repetition. We have A, we have B, we have C, and we have D. All right. So that is A union B. Let's go to the next question. Now, question 2. Find the intersection of set C and D. C and D. Intersection of set C and D. C intersection D. Okay. So let's see the element common to C and D. That's definition. So 1 is not common, 2 not common, 3 not common, 4 not common. Oh. No element is common. And what do we call that kind of set? That is what? Good. Empty set. So we can denote it with this. And question 3. Find the complement of the set E. What is set E? Is what? X, such that X is prime number less than 10. Set E, prime numbers less than 10. Do you remember prime numbers? What are prime numbers? Wow. Prime numbers are numbers that have just two divisors, two factors, 1 and themselves. So let's look at 1 is not a prime number. Yes, you need to know that. Okay, so what are the prime numbers? We have 2, we have 3, they have given us the universal set there. So we have 2, 3, 5, 7. That's all. Yes, 9 is not a prime number. Yes. So we need what? Find the complement of set E. The complement, how do you represent that? E complement equals elements that are not in E but are in the universal set. What are the elements? So let's compare. 1. 2 is here, 3 is here, 4 is not. 5 is here, 6 is not. 7 is here, 8 is not, 9 and 10. So these are the complements of what? The set E. So our conclusion. So set our foundations for many mathematical concepts, and then we have some regular practice. We also make you to understand sets better. Before we go, let's take a practice question. Yes, try this question. Task A. Let A be 1, 2, 3, B 2, 3, 4, and C 3, 4, 5. Find the following sets: A union B, B intersection C, and A complement. So I give you just 30 seconds to look at that. All right, welcome back. I hope you got that. Yeah. Yes, that's good. So let's look at it together again. Set A, set B, set C. A union B. Don't forget, what is union? Union means what? Merging the two sets together without repetition. All right, thank you. So A union B. A union B. Okay, so we have 1, 2, 3, and 4. Yes, that is A union B. A union B. Let's go to the next one. B intersection C. B intersection C. B and C. It means the common elements in B and C. Let's see. 2 is not common. 3 is common. Good. 4 is common. Yes. So B intersection C. B intersection C will be set of 3, 4. 3, 4. Yes. That's good. You got that? Wow, that's great. The last one. Find the complement of set A, assuming the universal set is 1, 2, 3, 4, 5. All right, so don't forget, complement of a set. It means what? Elements that are not in A, but in the universal set. All right, 1 is in A, 2 is in A, 3 is in A, 4 is not in A, and 5 is not in A. So A complement is 4, 5. All right, I hope with these little things, you should be able to practice more to understand it better. So if there's any question, comment, you can use the link shown on the screen to reach us. Thank you very much.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.